Okay, welcome to a video on lesson 35, and the topics are change in coordinates and the distance formula. However, before we jump into that, I have discovered that in one of our previous lessons, I failed to go over a topic called decomposing functions. And so number 9 from the previous homework set actually dealt with this topic of decomposing functions. It's a really simple topic. FXNS, by the way, is abbreviation for functions, right? Decomposing functions is a really simple topic. Basically, it says that you need to recognize that when given a composite function, that's a function that is more than one function combined in a way where you're plugging one function into another. And so that's this example here. If I say that square root of x plus 1, square root of x plus 1 is the combination of two functions, then it would be easy for me to identify that the outer function is square root x and the inner function is x plus 1. All right, so that if I take the way that this f circle g, or f of g, tells us to do, it says to take the g function and plug it into the f function. Well, if I take this function and I plug it into f of x, I end up with the original that was given, the square root x plus 1. So decomposing it means to identify which functions were pieced together to get the function that you were originally given in the problem. All right? So if I take the x plus 1 and I plug it into square root x, I get square root x plus 1. So that's the most obvious, I think, decomposition of this square root x plus 1 function. Over here, I've got another example showing three functions pieced together. So if I assume that h is the composition of a couple of functions, and h is equal to this that I'm circling here in green, then it's easy to kind of work from the outside in. The outer shell of this is that it's a rational function. It's 1 over something in the denominator. So I'm going to let f of x be 1 over x. Then I've got a square root going on. So if I replace the x with a square root x, then it's easy to see that just f of g would be 1 over square root x. Then all this stuff inside could replace that x. So if I let j, I'll just call it j, be all the stuff inside, then if I take this x plus 2 and I plug it in for that x, I end up with the original here. So in other words, what we're saying is that h is the composition of j plugged into g, and then that result plugged into f. If I plug j into g, I should do it this way, j plugged in here for that x, and then I take all of that mess and I plug it in here for this x, I get the original, this h here. All right, so that's a simple explanation of decomposition. It's really a basic topic. I don't want to spend any more time on it than we have to. Hopefully that's going to be enough. All right, so let's move on to the actual topic of lesson 35, which is change in coordinates and the distance formula. The most important part of this lesson is the distance formula. I'm going to tell you that straight up front. You got to know the distance formula. You got to memorize it. It's going to be something that carries on from this point on. It should also be a fairly simple concept. But before we get to there, this topic of changing coordinates. So imagine I had a number line, and again, you can pause the video, by the way, if you have to. Pause the video, consider taking time to write down the example, write down the notes, and then catch up by pressing play again. All right. If I had a number line and I was wondering about the distance between 2 points on a number line, we'll say the points are 3 and -8. And I'll say that the coordinates are, coordinate 1 is -8, coordinate 2 is 3. All right, I could find the distance between these in two different ways. I could say the distance is simply the difference, -8 minus 3. And since it's a distance, I would consider the absolute value of this, which gives me the absolute value of -11 or the distance 11. So the difference between the two. Just for the record, this triangle here means change in. I don't know if we've talked about that, but I'm going to say it now. It stands for change in. And anytime we're doing change in mathematics, that literally means to subtract. All right? So I did this by saying I took C1 minus C2 to get negative 8 minus 3, which gave me negative 11, which absolute value of which was positive 11. But I didn't have to do it that way. I could also have done 3 minus negative 8. And 3 minus negative 8 gives me 3 plus 8, which is 11. And of course, the absolute value of 11 is still 11. So no matter how I do it, I'm getting that the distance between these 2 points is 11. Of course, you didn't need to do any of this math to figure it out, but that's a foundational strategy for what is coming in the actual example, example 1. All right. Below it here, I've got these 2 points listed. I just basically came up with these 2 points, negative 2, 1, and positive 3, positive 5. If I wanted to know the change in the x-coordinates, I would simply subtract the x-coordinates. And usually we take the second coordinate given and we subtract the first coordinate, but it really doesn't matter as long as you're consistent with it, right? You've done this plenty of times when trying to find the slope of a line. You would subtract the 2 y-coordinates, maybe do 5 minus 1, and then you subtract the 2 x-coordinates, 3 minus negative 2. And as long as you did the same order, you would get the correct slope. All right, so if I do, for x, if I do 3 minus negative 2, it's of course 3 plus 2, which gives me 5. And if I do change in y, again, the triangles mean change in, this would be 5 minus 1, which of course gives me 4. All right, so change in literally means to subtract. Another way to represent this, if I slide all of this over, would be to say the change in x is x2 minus x1. Actually, I don't need to slide it over that far. It's the first x-coordinate, I'm sorry, the second x-coordinate, which we said was 3, minus the first x-coordinate. All right? And of course, on the bottom, it would be y2 minus y1. All right? So again, that's a foundational concept we've done before. Let's jump into the example. Example 1 says, what is the number whose graph is 2/3 of the way from 3 to negative 7? 2/3 of the way from 3 to negative 7. What is the number? So there's some number in here, in between the two, some number, in between these two values, 3 and negative 7, that is 2/3 of the way. Now we have to note that we are moving from 3 in this direction towards the negative 7. I don't know why I keep skipping on me here. From 3 in this direction towards negative 7. So 2/3 of that distance. Well, first thing I need to do is find that distance. So I would, again, subtract the two values. So we could go, let's say 3 minus negative 7, which gives me 10. The distance is 10. Now I need to know the number. The number that is 2/3 of the way from 3 to 10 is, I'm going to change this color here, sorry, is a number that starts with 3. Again, starts with 3. This is our starting point. We always have to be careful. When doing problems like this is the part that most students forget. We have to start at our starting point. It says 2/3 of the way from 3 to 10, or sorry, to negative 7. So we have to start at 3. And then the distance between them is 10, and so it's 2/3 of the way to 10, 2/3 of 10 that we are moving. But we are actually moving in a negative direction. So we're going to go minus 2/3 of 10. All right, so we start at 3, and then we do minus, because we're moving to the left, 2/3 of 10. And of course, 2/3 of 10 is what? 20 over 3. So we've got 3 minus, well, let's do 9. 9 minus, 9 over 3, sorry, minus 20 over 3. and I'm out of space here, so let me do a little organizing. Bear with me 1 second. I'm just going to slide this down a little bit. All right. So 9 over 3 minus 20 over 3, of course, gives me 11 over 3, which is about, negative 3 1/3. So 2/3 of the way from 3 to negative 7 would place me somewhere around here at negative 3 1/3. That's 2/3 of the way. All right. I don't know. Maybe I could shift it over just a slight bit. Say this point moves, about right there. Of course, on a number line, it's easy. We just go, okay, well, let's just approximate 2/3 of the way. 2/3 of that total distance is maybe right about here. All right, but the actual number is negative 3 1/3. So two areas, again, where students struggle with this type of problem, even though it is really just basic arithmetic. You're just subtracting numbers, multiplying and subtracting numbers. One of the areas they forget is, again, they forget to do the starting point. You always have to start with whatever we're starting from. If it says from 3 to negative 7, we're going to have to start with the number 3. Of course, we began the problem by finding the distance between the two numbers. Then, if we're moving from the right to the left, we have to subtract. If we're moving from left to right, we would make this an addition. All right? One more example. If you want to pause the video, try this example on your own, and then come back and look at it, that might not be a bad idea. All right, so in this example, we're given much more complicated numbers. We're asked, find the number that is 5/11 away, or of the way, from 3 1/8 down to negative 3 5/8. Well, I've already taken the liberty to change 3 1/8 to 25 over 8, and negative 3 5/8 to negative 29/8. All right, so the first thing I'm going to do is try to find the distance between them. So if I just subtract the two values, I'll say the distance d is 25 over 8 minus negative 29 over 8. All right, just subtract the values. I could have done negative 29 over 8 minus 25 over 8. I could have swapped these two, swapped them. But if I did that, I would need to account for the negative, maybe do actually, I probably could leave the negative on there and work with it like that. But either way, I just need to be aware that I am starting here at positive 3 1/8, and I'm moving in this direction towards negative 29/8. All right, so my distance between them is what? Looks like 54 over 8. All right, I think it's 54 over 8, right? And when you divide, it looks like I can divide both of them by 2, and I'm going to get 27 over 4. So the total distance between them is 27 over 4, which, if you're doing the math here, is what, 6 3/4, right? 6 3/4 distance. The distance between them is 6 3/4. All right. So the number we're looking for, I'm going to call it n, starts with 25 over 8. That's my starting position. And then I'm moving to the left. So minus 5/11 of means multiply. So it's 5/11 times our 27/4. 5/11 of the distance 27/4. All right. So we got a little fraction mess to work around with, or play around with, and that's leaving me with, I'm going to jump down to the next line here. That's leaving me with 25 over 8 minus, I don't see anything that's going to work very nicely with this one, unfortunately. 25, let's see, 5 times 27 is 135 over 44. And 25 over 8 minus 135 divided by 44. It's just weird, ugly fractions, unfortunately. Comes out to 5 over 88. And notice 5/11 is a small number. We're not moving a whole lot. 5/11ths of the way. That's not even, well, actually, I guess that's a little more than halfway when you think about it. It's a little more than halfway. So 5/88 is the number we're looking for. And that's going to put us right around here, 5/88, pretty close to 0. All right. Again, my number on the number line sits right here, 5/88. All right, I'm going to pause the video here. The next video is going to be on the distance formula. It should be a real short video.